Hello, everyone. We are live. Thank you very much for attending this live stream webinar and demo about SAFE and the EIP-7702. Also, thank you very much if you are watching this video recorded on YouTube several months after its publication. This means Ethereum Pectra was released. And you are lucky because then the EIP-7702 is live and you can use it with SAFE. And if you are watching this video several years after its publication, then thank you very much for coming back to the origin. These were the good old days where people used to work on proof of concepts, like this one we are sharing here today. And probably, and hopefully nowadays you have a great UX that you forgot how it used to be in the past. So who are we? My name is Germán. I work on developer relations at Safe, and I'm with my colleague, also working at Safe, Akshay, who is a Solidity engineer. Hello, Akshay. How are you?
Hey, Arman. I'm doing good. Great to be here.
Awesome. Ready for the session today?
Yeah, let's get started.
Cool. Then I will proceed to share my screen with the agenda for today. And there we go. So today we are talking about SAFE and the EIP-7702. I will start with a very light introduction to the EIP. Then I will show some resources that we are creating at SAFE, so you can learn from them or read what we are doing. Then Akshay will share the different approaches, three that he was working on how SAFE can support this EIP-7702. He was also working on a proof of concept demo, so we can see an example application and how it works, and also going through the smart contract changes that are needed on these different approaches. And finally, we will have a Q&A session where you can ask some questions, suggestions, or feedback you have. So let's start with the introduction. With the title set EOA account code and the description add a new transaction type that permanently sets the code for an EOA, this EIP is for Ethereum a step forward towards full account abstraction by enabling EOAs to run smart contract code directly from their account, from their address. This is possible because EOAs can store in the local storage an address that is called the delegation designator that is pointing to a smart contract that has some code. Every time or when a transaction is sent to the EOA, this EOA, similar to how delegate call works, will execute the code that is in this address and run it. This makes externally owned accounts have all the benefits or most of the benefits that smart accounts have. So let's check some of them. One of the most important ones is sponsored transactions, meaning that paymasters can pay for the transaction fees of these accounts. This is especially useful when onboarding new chains and you don't have the native token, for example, but also any transaction. Also very relevant are batch transactions, allowing to send multiple transactions with just one signature. Very relevant as well when giving approval of ERC20 tokens to smart contracts so they can spend it. Also, another of the benefits smart accounts have are passkeys, allowing users to sign transactions from with their credential in their devices. session keys as well. For example, if you log in into an application and after that you give them permission during a set time frame to execute transactions on your EOA. Also, granular permissions to other accounts, for example, meaning that you can, or that the EOA could sign sub-accounts or sub-keys so they can have access to a specific, let's say, transactions or tasks that this EOA can do. For example, sending a percentage of the funds in the EOA or calling specific contracts, etc. Assets recovery is also very important for EOAs. Currently, they still have the private key is not removed when they have the smart contracts features. But if you set a recovery mechanism to your EOA and you lose the private key, then you will still be able to access the funds through this way. Also, revocability, meaning that the delegation designator can be replaced or revoked anytime, and many more. This has a big impact, especially onboarding to Web3, because it becomes much more easier. More users will become more comfortable using smart accounts because they will still have their EOAs, their EOA functionality or way of working. And hopefully we will see more smart account users than EOA users in the coming years. Some resources we would like to share with you are the docs.safe.global, our docs, our blog as well, YouTube channel at Safe Global, and the GitHub experimental organization we have at Safe, which is 5AIF, with the repository that Akshay will show later. And if we go to the docs here, we can see that we have several tabs, one of them being advanced, where we have some features with different ERCs or EIPs. And we have the EIP-7702 with an overview of what it is, how the signing process looks like, and then how it works with Safe, showing the different approaches that Akshay will talk about and how the EOA goes through the different steps and what is the status of the code and the storage. As a reminder, all these three approaches are experimental so far, and the contracts are not yet audited, so use them at your own risk. Now I will stop sharing my screen and I will give the mic to Akshay. Yeah, so stage is yours.
Yeah. Thanks, Germán, for giving a quick intro on 7702. I think that was sufficient to go into more details, and then I will cover further what approaches we have for safe and using 7702 once it's live. I will quickly share my screen. Do you see my screen now?
Yes.
Yeah, cool. So we have different approaches for in EIP-7702 and using safe accounts. And why do we need those? So the first problem with using existing safe contracts with EIP-7702 is that they are prone to front-running attacks. In case an EOA delegates to a safe singleton in its current state, anyone, a malicious actor can look at the mempool, see the transactions and authorizations that are coming in, and call a setup function on the EOA once it's delegated to a safe singleton and take over the account. So it's very risky to do so, and we need to do something about it and block front running attacks. So we have discovered many approaches to do so. We are going to share 3 possible ways here right now and go into the code of each. And we also have a demo with a UI on how to use one approach. So coming to the approach one, we have a modified safe proxy where we change some logic in the standard safe proxy contract and a minor change in the safe singleton as well, but that's an optional change. Um, by doing this, users EOAs can delegate to a safe proxy, which delegates all the coming calls except the setup call to a safe singleton. That's approach one. We will go into features and drawbacks of each and code in further slides. The approach two is modified safe singleton, where we altogether remove the use of safe proxy and just have a modified safe singleton to which the EOS can sign authorization by the format which EIP-7702 specifies, and they can just start using their EOA wallets as safe accounts. That's approach two. It has many more changes than the first approach. And we will go into the code details later. And the third approach is a very different approach from the first two approaches, which is SafeLite. It's a minimal small contract implementation where users could delegate to this SafeLite account, and it has some minimal features that they can use. Like the 2 features they can use is batching the transaction and getting the transaction relayed. So let's go into detail of each of the approach now. Yeah, so the approach one, modified safe proxy contract. In this approach, EOA signs a message which would set the authorization, that is the code, to a safe proxy. The address of the safe proxy will be dependent on the initializer data, and we will further discuss what the initializer data is and how it will look like. And then safe proxy has a function called setup, which is used for setting some storage of the EOA. And then any other calls are delegated to a safe singleton. So that's approach one. And how does it work? So first thing, the address of the proxy depends on the initializer data. So what is initializer data? The initializer data is the data like what would be the owners of the safe account, what would be the threshold, modules to be enabled, what fallback handler address should be, anything related to payment for execution of the transaction. So all this data. This is different from the standard safe proxy that we have, where the address only depends on the address of the singleton, which is sent in the constructor. Here, the address also depends on the initializer data. It is important because it prevents front-running attack. How does it prevent front-running attack? We will go into the code later. And in this approach, user signs an authorization that delegates to a safe proxy. So if you would check the code of the EOA to a chain that has enabled EIP-7702 feature, you will see a format where the first 3 bytes would be some standard bytes defined by the EIP, and the following address would be the address of a safe proxy. So what are the features of this approach? The major feature is that user has to sign the authorization only once, and the subsequent calls of through setup function can be relayed by any bundler or a paymaster or any relayer as such. So we don't need to sign multiple times for once to sign an authorization and once again to initialize the data of once again to sign the initializer data. This approach is almost compatible with Safe Wallet, so users could import their EOS into the Safe Wallet itself without many changes to the wallet UI. There would be some minor changes required, but not a major overhaul. And existing safe infrastructure could be also used in this approach. Yeah. What are the drawbacks? The drawbacks would be that this approach requires deployment of a safe proxy contract. So the costs on expensive chains would be higher for deploying a proxy contract. Uh, that's one thing to be considered. And other drawback would be that um, mm, we need a slightly modified safe singleton so that address this can be the owner of the of the safe when it's running under the context of EOA. So with the standard safe singleton, we have a check in the code while setting up the owners that the address itself cannot be an owner of a safe, which is a right assumption because safe accounts or smart contracts do not possibly don't have a private key, and making them the owner itself doesn't make any sense. But with EIP 7702, when an EOA delegates to a safe account, the owner can be the EOA itself because the EOA has a private key and it can be used for signing transactions. So we need a slightly modified safe singleton in this approach. And another drawback of this approach is that it requires calling a setup function which is used to set some storage on the account, which is again an additional step for the users to start using their account. So signing authorization and then calling the setup function again. That's slightly the two-step process. Yeah, and let's go into the code for this approach. What smart contract changes we did, and let's just discuss them. First change that this approach does is that the setup function is moved from safe singleton to safe proxy. Actually, it's copied. It still exists in safe singleton, but it won't be used. The code is the code of the setup function is the proxy contract. Mm. And it has slightly modified changes. We will go in them now. And the second change is that modified safe singleton, which I already talked about, like EOA, so that EOA as the owner of the safe proxy can be used. And one more thing we did with the proxy in these modified safe proxies that we made it such that it cannot be used. It's just a precautionary measure, not required, but we still did it. Yeah, so let's go into the code changes of these. Yeah, so we have a repo here, Faith, Safe EIP-7702, and it has some, this is a kind of a monorepo where we have a backend and front end for demo and some smart contracts. So let's go into smart contracts. We'll go into the demo and backend at the end of this presentation. So in the contracts, we can see that we have a safe EIP-7702 proxy contract. This contract inherits standard safe proxy contract with some changes. If you compare the constructor of a safe proxy and safe EIP-7702 proxy, bytes 32 setup data hash, this is an additional parameter. And by doing so, that is making it a part of constructor, the address of this proxy will be dependent on the parameter setup data hash. And it's used further if we check in the setup function here. So whatever parameters and its values are received in the setup function, we hash those and check if it matches with the parameter that was sent in the constructor. And this prevents front-running attack by in such a way that whenever a user signs an authorization to a proxy contract, its address will be dependent on these parameters. So effectively, no malicious actor can change these parameters and change the owners and threshold or any other value the data here and call the setup function. It has to be called with exact parameters that so that the hash would match. So these are the two changes here. And then one additional change is that we set the storage slot 0. That is the singleton address in the setup function. If you compare with safe proxy, it's a little bit different. So that we have storage initialized here. And then we call the setup function of the singleton contract after doing these two things. So we use other logic of the setup of a safe account that exists in the safe singleton itself with these changes. And one more thing that we have here is we are making this proxy unusable. Why do we do so? Is that this proxy is meant to be used with EIP-7702. There's no harm in using this proxy standalone, but we are just doing it as a precautionary measure and making it such that it cannot be used for other purposes other than receiving calls from the EOA and delegating them to the singleton. So the storage of this proxy contract will be never used, and it will be just empty other than this storage slot. Yeah. I think that was the approach one. And one more change in the approach one is that we also have a slightly modified safe singleton contract. Let's go into those changes. So if we go into this safe global safe smart account repository and this branch feature EIP-7702 branch and see safe dots, sorry, if we see owner manager contract, we have this commit allow owner as self. And if we look at the changes, we have this change at line 41 and 42, where we remove this check where address cannot be the owner itself. So after removing this check, the owner in a safe in the context of safe account can be the address itself. That is, when an EOA delegates to a safe proxy, which would delegate the calls to a safe singleton, the EOA address can itself be an owner of a safe account. Otherwise, users would have to maintain another private key to add an owner to an EOA converted to a safe without this change. So we are by removing this change, only one private key is enough for signing safe transactions and one for signing authorization. So these are the minor changes that we did to the safe singleton contract with major changes in the safe proxy contract. Let's go over to approach 2. So as I had told before, in approach 2, that is modified safe singleton, EOA would sign an authorization message, which would delegate to a safe singleton rather than delegating to a proxy, which delegates to a safe singleton. So effectively, we are removing the use of proxy here, and users directly delegate to a safe singleton, which would save some costs of deploying the proxy. So let's go into more details. How does it work? Yeah, so this safe singleton is compatible with EIP-7702. We did some changes to the setup function. We'll go into the code details soon. User sign authorization that delegates to the safe singleton. I already talked about it. And one more thing that users would have to do is they would have to sign over the setup data. So we require 2 signatures from the users to start using the EOA as a safe account. That is, first they have to sign an authorization and then again sign the setup data, which would be used for setting some storage values on the account. What are the approaches? It can be compatible with Safe Wallet with some minimal changes. Currently, Safe infrastructure, how it works is that the storage slot 0 of the smart contract account is used to detect what singleton is the account using. But in this approach, this storage slot 0 is empty because there is no proxy, and there is no need of proxy, so we don't need to store the address of the singleton. So safe infra would have to be slightly adopted to detect these kind of cases where EO is directly delegated to a safe singleton and the storage slot 0 is empty. It keeps all existing safe features as it is. Nothing changes much. Users can use modules, add some additional features to their account, change the owners, change the threshold. They can have fallback handlers, guards as it is. So nothing else in the safe account features change. Yeah, and we don't need a proxy. What are the drawbacks? So some heavy resource investment is required because we have to do the auditing. It takes some time, and then we have to also invest in formal verification as we are doing some contract changes that are very critical to the account, and some changes to safe infra as well. Let's check into the code now. What changes did we do? In this approach, we did some changes to the setup function. We blocked out the existing setup function on the safe singleton and introduced a new function called setup EIP-7702, in which we have some parameters changed. We'll go into those now. And one more unique thing to this implementation is that the default owner of the safe account will be the EOA itself with a threshold of 1. Users can also add new owners later if they want to, or even in the setup call itself, there are other ways to do so. Let's go into the code changes now. Yeah, so if we go into the safe global / safe smart account repo with branch feature EIP-7702. In the contracts folder, there is an experimental folder which has safe EIP-7702 contract. This contract inherits standard safe contract with these changes. You can see that the setup function is blocked, cannot be used. Any calls to setup function will be reverted. This is to prevent front-running attacks, and as a method to provide additional setup, we provide setup EIP-7702 method. If we look at the difference between the two, the owners and the threshold parameters have been removed in setup EIP-7702 with an assumption that the owner of the safe will be the address itself, that is the EOA address with a threshold of 1. And there's new parameter called signature, which is the signature of the data derived from these parameters. So once we set up the owners, modules, and everything, then at the end we check the signatures, whether the user really signed over this data or not. So this prevents front-running attack because we check the signature if it was signed by the owner of the safe or not. These are the contract changes that need to be then audited, checked if it's okay or not. Yeah, this is approach 2, and let's go into approach 1 now. Let's go into approach 3 now, which is SafeLite. This is a very minimalistic contract which does not have any fallback handlers, no modules, no guards. Just it supports batching and relaying of transactions. So what changes do we have? Managing of storage slots becomes easier. So this contract follows a standard which was proposed for using the non interfering storage slots for the accounts. So if users want to hop between different account implementations, it will be much easier than using safe singletons if the other account implementations don't use storage slot zeros. Mm, uh, and to support changing between account implementations for the EOS, there is also an ERC-7709, um, which they can use, and it will be much more easier and compatible than while using different account implementations. In fact, users can also use safe singletons and delegate to different accounts and then come back to safe singleton or safe account implementation, but there can be some risks to do so if some storage slots that safe uses have been used by some other account implementation for other purposes. So one thing that we have to consider for signing authorizations is that we cannot use EOA wallets in the for signing the authorizations because they don't support this signing method. Let's go into the code of SafeLite first, and then we can talk about these things again. So how does code SafeLite look like? So we have this repo safe EIP-7702, where we have these experimental contracts, and there is SafeLite here. So if we check the SafeLite, it has only one storage slot, which is used to track nonce, which helps to which helps to prevent signature replay attacks. And what else does this contract support? It natively supports ERC-4337, so users can use bundlers and paymasters, and they don't have to hold native token balance to pay for transactions. This contract also has a multi-send method implemented natively, which helps to batch multiple transactions into one and can be used to transfer, suppose ETH to multiple addresses in the same transaction, or do other things like approve and swap in the same transaction. And there's also this contract also supports ERC-1271, which is used for validating smart contract signatures. One more thing, if you check out this contract, you will notice is that there's no setup function. Actually, because we actually don't need one for initializing the storage. The storage nonce will start with 0. And does not have there is no other storage slots used. There are no other owners, no threshold, no modules, no fallback handlers, no guards. So there's no need of calling a setup function, which is nice because users have to just sign the authorization and their account is converted to a SafeLite account and does not require additional costs for calling the setup function and setting up the storage. Let's go into the demo part now for one of the approaches that we have. Yeah, actually, one more thing before we go over the demo. Wanted to talk that um, one important thing with any of the implementations with EIP-7702 is that the private key of the EOA still can be used for overriding any of the logic that a smart account implements. It's not just specific to safe, it's generic. Recovery is possible if user still holds the private key of the EOA. So if the account implementation goes rogue, users can delegate to some other account and they can have access to that address. But with if the private key gets stolen, the account is not protected from the theft. Because if the private key is stolen, no matter what the account logic is implemented to prevent thefts, the private key can sign new authorizations, which would delegate to new account implementations, and whatnot. Yeah. For going through the slides, please scan this QR code. I will just wait for a few seconds, and then we can go over to the demo. Yeah, I will go over to the demo now. So just a second. Yeah. So we have this demo UI, which uses approach one. Approach one was using a safe proxy account and a slightly modified safe singleton to convert EOAs to safe smart accounts. Um, we have an embedded wallet here because existing wallet providers don't provide a signing method for signing EIP-7702 delegations. So mm, just assume that this wallet is imported here. Users can go and change the private key. I'm not showing it here right now. And we are using a testnet called Ithaca for this demo. If we check the storage of this account, which is an EOA account, it's empty right now. The safe singleton address is 0. There's no fallback handler. Threshold is 0. Nonce is 0. There are no owners. The account has not been delegated to a safe account yet or any other account implementation. There are no owners and no modules. So it's a fresh account with nothing, never used, never initialized. And just let's go and see what we can do with it now. Yeah, so this is the account setup page. It has some defaults. The signer one will be the account itself. You can change it if you want, but right now let's keep it as it is. And the threshold is set to 1. Users can change these parameters. And there's some default configuration, like what proxy factory contract to use for deploying the proxy contract, safe singleton implementation to use, fallback handler address. This fallback handler address is the ERC4337 module address. And so by default, this account, this EOA will be compatible with ERC4337 once the authorization has been signed and executed. And its specific, the authorization will be valid for only this specific chain ID in this POC. The EIP also specifies that if the chain ID 0 is used, the same authorization can be used across different chains. But now we are sticking to just one chain ID. And the UA nonce is here is 0. So it's a fresh account which has never executed any transaction on this testnet. So this UI presents that there will be some proxy deployed at this address. It's just informational right now. Let's sign an authorization. Authorization is now signed and ready to be relayed. There is a backend service here which would collect this signed message from the user and relay it on chain, so users don't have to hold any native token balance in the account to execute this signed authorization and convert EOA to smart account. A relayer will do it for them. So now let's execute this. So we have a transaction hash, and the account is now converted to a safe account and can possibly also used with safe wallet. Or even we have a small implementation for batching and executing transactions through this EOA, which I will show you now. Right now we are not using safe wallet. We need safe infra setup for it, which is not there yet. But let's check out the transaction hash and then we can go over to the demo of batching. So if we see the transaction hash, it is a type 4 transaction, which is introduced by EIP-7702. And it has been executed by some relayer and not the EOA address itself. So if we check, 6F7E is the account that got converted to a safe account, but it was done by some other relayer service. So users don't need to pay for the transaction to be executed. And there's some bunch of data here, which is the initializer data is used for deploying a proxy and then executing the setup function in the context of EOA. So this is the transaction, and let's view the storage of the account now. So you can see there are some numbers now where safe singleton is set. There's fallback handler at some storage slot. There's threshold. There's the safe nuns, which is right now 0. Um, there are owners, which is owner count 1, and the owner of this account is itself here. So we can now be sure that this EOA is converted to a safe account with owner count 1, and the address of the owner is the EOA itself, and there are some modules enabled to it. Yeah. So now let's do something with this. Right now we can see that the available balance on this account is empty. I would send some funds to this account and then we can just execute something through this account. Mm, I'll just send some small value to this account. Yeah, so this account has some ETH values which we can now spend. So in this demo, we will just send some small ways to 0 address, and this will be a batched transaction and relayed by a bundle paymaster using ERC4337. Now just let's execute this. The transaction has been executed. Let's view it on Explorer. So if we check the internal transactions, we can see that there was call from EOA to address 0, and it sent this much amount of ether to 0 address, and it was called twice in the same transaction. So using EIP-7702, we now batched a transaction through an EOA, and it was also relayed by some paymaster and bundler. If we check the state, the 0 address balance got increased by the equivalent amount that we sent. Yeah, I think that was it for the demo here, and we discussed 3 possible approaches that we could use for converting EOA accounts to safe accounts, and discussed for the pros and cons of each of the approach. Let's see if we have anything else to share. Germán, do you have anything?
Yeah, just say thank you, Akshay, for the very detailed explanation on the 3 different approaches and the great demo. I think overall we can say that the value proposition Safe is bringing here is entering the EOA wallet ecosystem with our battle-tested contracts. And ultimately, this will allow users to integrate their EOAs with the Safe Smart account, granting them access to all the features that we have without switching to a new wallet entirely. So I think this is what we wanted to present today. Now we have some times for questions, if any. Feel free to use the chat. We can wait a little bit if there is any question. Otherwise, that was it for today.
Yeah. Thank you.
That was it. Oh,
Yeah, I think that was it.
there's one question.
Oh, okay. There's this one question.
So it says, I know 7702 will be in the Ethereum next upgrade, but what about L2's Polygon? Is there a way to know the status of other chains?
Okay, so this EIP has been designed for multiple chains. If you look at the EIP proposal, it says that the authorization can be reused across multiple chains if the chain ID is 0. So it has been assumed that this EIP will be adopted by all other chains, but it's up to L2s to decide whether to support or not. But optimistically, they will L2s will approve it.
It looks that was it. As a general reminder, this video, this live stream is part of several content or pieces of content we are publishing. You can find them on YouTube, also the blog in our website, and also X for past and future announcements. So stay tuned and see you soon. Thank you very much for attending. Bye-bye.
Thank you. Bye bye.
Thank you.